Hey folks, today we'll be walking through the build of this double-decker walnut coffee table. This was one of my favorite builds to date. I absolutely love the way this piece turned out. One of the first things we do is remove all the external bark. This bark is very poorly adhered to the underlying wood and would act as a weak point if left on. There's a few ways to get this bark off, but hammer and chisel is usually my go-to method. I then come in with something like a wire wheel brush. These are extremely effective in digging through any remaining bark. This method will, however, leave a very rough, aggressive surface. For those pieces where a opaque black epoxy is used, this surface is not visible, so nobody will end up seeing those brush marks. This method also allows for a much better mechanical bond to be established between the epoxy and the wood, making the table significantly stronger. After the edges are prepared, I'll then flatten the slab.
This is done by kiss cutting the high spots with my CNC machine. Helps to ensure the wood is completely planar before it goes into the epoxy mold and prevents any excess epoxy from getting trapped underneath a piece of wood that is not flat. After flattening, the wood is ready to cut to its final shape. I'm using my 16-inch skill saw here, which I absolutely love. This saw will cut through just about anything. However, some pieces of wood have residual stress in them based on where they're taken from the tree, and they can act to close up and pinch the blade of the saw as you're making the cut. And that's exactly what happened here.
This was actually my first time using my new epoxy pour table, which is a 4 by 8 sheet of melamine sitting on top of a workbench with a 1/4 inch sheet of high density polyethylene placed on top of it. This material was selected because it very poorly adheres to cured epoxy and will allow a cured project to immediately separate from the mold. Next, we add a bit of caulking, which will help to make that epoxy tight seal around the four walls of this mold. For the walls, I used a couple of 4 by 4s wrapped in packing tape because packing tape very poorly adheres to cured epoxy as well. The mold is then pressed against the table with a couple of 2 by 4s and some clamps to help keep it nice and tight and keep all that epoxy inside the mold and not have any leaks. This mold ended up being just a bit bigger than the size I wanted this final table to be. You can see a bit of empty space on the left side. What I ended up doing was adding some caulking above and below it to help seal the wood in just the right-hand portion of the mold. Black walnut has a very porous grain structure with very large pores. And since we're using a black epoxy here dyed with an alcohol dye, that black dye can have a tendency to leach itself into the wood. So what's being done here is a clear epoxy is being used on all of the wood surfaces that are going to be in contact with the black epoxy. This seal coat using a tabletop epoxy will also help precondition these surfaces to make a good strong bond with the epoxy we'll be pouring in. This table called for 6 gallons of epoxy, and here I am mixing parts A and B. It's important to mix these while the material is still clear so that you can see any streaks that might be present of unmixed material. You really only get one chance at making sure all of the part A and part B are thoroughly mixed. So it's important to do that first, then add your dye. All of that preparation that we did then culminates in this step of doing the final pour and adding the epoxy to that river. I also take the opportunity to use a small cup to fill in any of the cracks or imperfections on the surface. Now, this part is arguably one of the most satisfying parts of the entire process. This is when you come in with a torch and you're able to pop all of those surface bubbles. It's important to let the material sit for a while and let those bubbles rise to the surface. And then you can come through and clean it up as we're doing here. Luckily, all of the caulking held here and this pour turned out perfectly. Once the piece is set for about 5 days, the epoxy is cured enough to the point where it can be removed from the mold. Epoxy progresses through 3 general stages as it goes through its curing process. It starts in the liquid phase, which is the state that it's in when it's initially mixed. And it's like that for about 24 hours, at least with this deep pour epoxy that I'm using. The next phase is the gel phase, which usually occurs between days 2 and 3. And the epoxy is the consistency of a thick molasses. After that, the epoxy enters its solid phase, where it is actively hard to the touch, but the material hasn't reached its final hardness or strength. The epoxy, over the course of a few weeks, will asymptotically approach its final strength and hardness. Now, these times are certainly temperature dependent. If your shop is too cold, it will take significantly longer, and if it's quite warm, this may happen faster. The other factor to take into consideration is the exothermic characteristic of the epoxy curing process. When epoxy pores are very large, you can get quite a significant amount of heat that's generated as a function of the material itself curing. This can be pretty dangerous because the material can go into what's known as thermal runaway. This is a feedback loop that is produced by the epoxy curing, generating more heat. The heat of the curing process then accelerates the cure, generating more heat. And the epoxy itself can actually burn, smoke, bubble, and discolor. I've had that happen, unfortunately, and it looks like this. The next step in the process is to flatten the slab. And there's a number of ways to do this. I luckily have a small CNC machine. So that's what I decided to use to get the top of this piece flat. The piece is small enough that it actually just barely fits inside of the working area of my CNC. I, I use a 1 inch wide flattening bit here with two carbide inserts that does a rectangular pattern and goes through and basically leaves a perfectly flat surface. I then flip over the piece and we'll do the bottom side as well. It does, however, leave some grooves in the wood and the epoxy that need to be manually removed. It also exposes small defects in the epoxy and bubbles as shown here, and those can be fixed pretty easily with some black super glue sprayed with an accelerant. I will usually build the molds for these tables just slightly bigger than the final dimensions. That's so that I have the opportunity to come back and cut the finished piece to the exact dimensions that I've promised the customer. For this piece, I added a small radius to all of the edges as well using a trim router. I enjoy these routers because they're light and easy to maneuver around these types of edges. Once the top of the table was mostly complete, I moved on to creating the leg. This is a rather meticulous process. There's a number of angles in these legs that all need to be cut precisely in order for the final dimensions to come out correct. Given the number of angles that needed to be cut correctly, I did end up making a CAD model, a 3D model of this table. That allowed me to gather the dimensions directly from the computer so that I could ensure everything was correct. This table has no fasteners at all. All of the joints are attached with a combination of dominoes and glue. Dominoes is a proprietary name from the company Festool for a joinery method known as a loose tenon. This is a joinery method where an oval hole is cut into one piece and a corresponding piece of wood is slipped into that hole and spans across the joint. This allows for long grain fiber and continuous fibers to span across the shear plane of a joint, significantly increasing that joint's strength rather than simply using glue. Now, I admit that I may have gone a bit overboard in making these dimensions here, but this is one of those things that as you're going through the process, you want to be very sure that your holes are in the exact correct location because you only get one chance to cut it right. What I'm doing here is something that I've unfortunately learned through painful experience, and that is ensuring that a dry fit is performed with all of your joints before you put glue on them. And for all of those building at home, please learn from my mistakes and do a dry fit. Once all of your joints are glued together, despite the care of cutting all of the angles correctly, you will inevitably have gaps. The method that I use to correct this is making a slurry mixture of glue and sawdust from the wood that's being joined. For some joints, you're able to achieve a more polished final look by opening the gap up and adding a small shim. Although this is on the bottom side of the table and likely no one will ever see it, it's important to me that even these joints look immaculate. You can then add your slurry mixture into the remaining gaps. This is a bit like sculpting and takes a little bit of finesse to get that material deep into those grooves. A playing card is a great tool that can be used to separate the teeth of a saw from the surface of the wood. This prevents any collateral damage while you're doing these type of small joint cleanups.
When I started building the lower deck, we had another example here of residual stress in the wood coming out. What happened here is, although I was just cutting off the end of this board, the wood had so much stress in it that it clamped on the saw blade and actually popped the breaker. I had to use the wedge trick here again to get that piece cut off.
It's important to put a little bit of thought into the order of operations of your build process. If one piece is going to fit into another piece, it's good to build the first piece in its entirety, then measure it before you begin cutting pieces for the second piece. In this case, we are building the lower deck.
Since I had already built the legs, which this lower deck would fit into, I was able to measure them, then use those dimensions to size the lower deck. I'm using the domino here to join these pieces together. I absolutely love this tool. It sits flush on the top of a board and allows for a very precise positioning joinery to be placed that allows two boards to fit together nearly perfectly. I use another woodworking trick to get this joint even more perfect. I connected the two faces of these boards, which would eventually touch each other, and cut them on the table saw in a single pass. That allows both sides of this joint to be cut by one pass across the saw blade. This results in an almost invisible joint once glued together. Since I already had the legs cut, I was able to cut this piece down to the exact dimensions that I needed it to be. Adding a simple 1/8 round over gives the lower deck a nice finished look. I even managed to match the taper of the lower legs on the edges of the lower deck. It's amazingly satisfying putting these pieces in and seeing them fit exactly as you want it. After getting the lower deck placed, I noticed that the bottom of these legs were slightly out of flat. I'm using a feeler gauge here and a straight edge to check how out of flat they were. Using a compass allows me to add an exact offset mark from that top rounded face. I then could sand mostly the center and have a reference for how much material needed to be removed. I wanted the short edges of the lower deck to match the angle of the legs here. So here I am marking it off, then cutting that exact angle with the track saw. This is similar to a process called match drilling, where two pieces that interface with one another are used as references to get an exact fit between two pieces. And again, playing cards are used to find the exact center of the lower deck between the two legs. Now, it took a bit to figure out how to get that position of the lower deck centered within the legs, transferred in a way that I can get everything glued together. What I ended up with was center punching a location on the bottom legs and using one of these transfer pins, also called a spotter, to then transfer a small divot into the lower deck. Everything is positioned using the playing cards, then a small amount of pressure is applied and it transfers a small depression from that transfer pin into the lower deck. That allows me to know where the location of a domino should be to allow everything to line up correctly. I first tried to use a shortcut and use my trim router with a small tipped end mill on it to cut my domino slot. However, I found out that there was a taper on that end mill, which wouldn't allow the correct depth to be cut. So I eventually conceded and brought the domino out. With a little bit of measurement and positioning, that cut was made quite nicely. This table was designed to be held together entirely by glue. There isn't a single screw or fastener in its entire design. After the glue was dry, the next step was water popping. I'm giving a nice healthy spray down of all of the surfaces with water. Allow that water to dry. It raises the grain. I then come back and sand with a 220 by hand. That knocks down all of the grain that would typically get raised when the finish is applied and allows for a much nicer, more uniform surface to be produced on the finished piece. After final sanding, after water popping, mineral spirits are used to clean the surface and get off all that residual sawdust. Wetting the surface like this also allows for the first opportunity for a preview to be had of what the finished table will look like. Finally, after hours of manual labor getting this table prepared, we are ready for the final step, and that is the application of the finish. I'm using Rubio Monocoat here, which is a hard wax oil. You combine the base material with an accelerator, mix it together, and simply wipe it on. Although it's called Rubio Monocoat, which implies only a single coat needs to be applied, I typically will apply 2 or 3 coats to increase the uniformity of the finish. This is also one of the easiest finishes to apply. You simply pour it on and wipe it down with a white Scotch-Brite pad. I found that the use of a white Scotch-Brite pad helps to drive the finish deep into the surface, even more than wiping on with a cloth would. Also, a scraper applicator here helps to uniformly distribute the finish across the surface. This is undoubtedly the most satisfying part of the entire build. It's the time when the real richness of the wood is finally exposed. This finish is also great because you can apply it over both the wood and the epoxy at the same time. In the unfortunate circumstance that there's any blemishes in your sanding of the epoxy, this is unfortunately the time when they will be exposed. After the finish is applied over the entire surface and allowed to cure, the top is ready for the application of a ceramic top coat. This material is applied to help provide abrasion resistance to the top of the surface, most specifically the epoxy. Also helps to provide a uniform, very luxurious sheen to the table. This is done as a two-step process. First, a base coat is applied, which helps to harden the surface. Then a top coat is applied to help bring out that final luster. The final step is to take a few glamour shots. This was an amazingly fun table to build. I really enjoyed the entire process. I hope you enjoyed the video and look forward to posting my next one. Bye for now.